Okay. All right. Okay. That homework number 13 is due this Monday, and then the final homework is due on Wednesday, December the 4th, and that's when we're going to have our last test on chapters, what we've covered in chapters 8, 9, and 10. All right. So in those first two chapters, we didn't cover the entire thing, so there were just a couple of sections from each one of those. I do have the take-home quiz. I'll be delivering that to the high schools this afternoon. I'll be handing that out towards the end of class today because I don't want you to be distracted by looking at starting to work the take-home quiz while I'm talking up here, all right? And then finally, I'll also be, just as I've done for other tests, I'll be finishing up some test review questions, and those should be ready, available by Monday, okay? All right, so we're talking here about, we're on section 10.5, and we're talking about conic sections. And then we've looked at parabolas. Now, and first of all, what we've looked at is that these are centered at the origin 0, 0 to make oops, I better increase this for you guys, sorry. That's pretty small. Okay, there we go. And it's centered there to make the algebra easier. And we got some equations for parabolas where if the parabola can either be going up this way or it could be going down this way, all right? And when it's oriented in either of those two directions, the equation then where it's centered, this is 0, 0 here, 0, 0. It's going to be x squared is equal to 4py, all right? And p basically is the distance between 2 times p is the distance from each point to the vertex plus, to a focus, plus the distance between that point and what's called a directrix. Okay, that's a terrible diagram. We have the 0, 0 here. We have this line here that's called directrix. Y, in this case, it would be y equals negative p. We take any point here on the parabola, and we have a focus here, f. And the distance here, when we add up the distance here and the distance down here to the line, that is a constant number. All right. And we're saying that distance is 2p. And it's equal to 2 times p. All right. Okay, now it's x squared equals 4py if it's going up or down. Now, if it's going up, the p is greater than 0. If it is going down, so we have a directrix up here, then the p would be less than 0, and then it would still be y equals negative p for our directrix. Here, we're still calling that 0, 0, and we have a focus right there inside the parabola. Okay, and so that's still represented by x squared equals 4py, but that's going down below. So that's for p less than 0. And then the parabola can also go to the right or to the left. It can also go this way. Here, this is 0, 0. Or it can go this way to the left, 0, 0. And then here we just interchange the x's and the y's. So this is going to be y squared is equal to 4px. Our directrix is going to be a line outside of the parabola, and that's going to be an x equals negative p and x equals negative p. All right. And then in this case, the p is going to be, if we're going to the right, the p is positive. If we're facing to the left, the p is negative, right? Okay. The way to remember this is that if the y values are getting really big compared to the x values, it's either going to go up or down. So that's x squared equals 4py. Here the x values are getting really big compared to the y values, and so it is y squared equals 4px. It just depends on which way it's going. Okay. Then we looked at, okay, any question here? I know this is very quick on the parabolas. I just want to emphasize the 4 ways they can face, and they have the focus is right in here. Okay. And the focus actually would be at, this point here would be p comma 0, and this point here would also be p comma 0, but here p would be negative, so it would be a negative value on the x, all right? All right, then we looked at ellipses, and ellipses are basically elongated circles. So again, they have actually 2 different ways. They can either be like this, elongated along the x direction, or they can be elongated along the y direction. And they have 2 foci, and they're on the inside of the ellipse. And basically, we're assuming, for sake of simplicity, that these ellipses are centered along the origin 0, 0. So centered very nicely along the origin of 0, 0. Okay, if the ellipse is going sideways, so to speak, it's going to have this formula x squared over a squared plus y squared over b squared equals 1. So we have a plus for the ellipse. If it is going sideways, the number under the x squared is bigger. It's the bigger number. If it is going up and down, we can still have the same type of equation here for the ellipse. But if it is going up and down, the number under the y squared will be the bigger number. So you don't have to so much worry about A and B. It's just the bigger number will tell you whether it's oriented horizontally or up and down. Okay? And these have, okay, so the couple things with this, these intercept here along the big axis, along the major axis. Those are called the vertices. Here our major axis is up and down like this. These are the 2 vertices here. All right. And the vertices are basically going to be from this bigger number here under the, that's in your equation. So in this case, we're saying our A is bigger. The vertex then, it's centered at 0, 0. The vertex then would have an x value of A. We're assuming A is positive, and then a 0 for the y value. This is from the bigger number under the x, and then the other vertex is going to be negative a, 0 for the y. With this case, where the number under the y is bigger, the vertex here is going to be along the y-axis. So our x value is going to be 0. Our vertex y value is not going to be b squared, it's just going to be b. And then down here, it's going to be 0 comma minus b for the vertices. And then we have these things, these two foci that actually generate this thing. Those are found by just taking the square foci, just taking the square root of the bigger number down below here minus the smaller number. So in this case, it would be a squared minus b squared, and then we'd have a plus or minus there because we have two foci. Here the b is bigger, so the foci is going to be the square root of the bigger number minus the smaller number, and again plus or minus there, okay? And we did a couple of examples here with the ellipse last time. This is just a kind of a quick review. All right, what we want to look at next then is the hyperbola. That's the third conic section. And it has a lot of similarities to the ellipse. This is where the distance from a point on the hyperbola, the distance from it and the foci and the focus minus the difference. If we look at the two foci and we take the difference of the distances, that's equal to a constant. With the ellipse, we take the sum of the distances, and that's equal to a constant. So the hyperbola then can also go in, just like with the ellipse, can go in two different directions. Here's our xy. Again, we're talking about centering the whole thing right now at 0, 0 to make the algebra easier. One way it can go is this way. That would be oriented in the x direction. The other way it can go is oriented in the y direction. All right. So we have two separate parts with the hyperbola. Now, the equation here, the ellipse was a plus between the two terms. The hyperbola has a minus sign between the two terms. Now, if it is going, this is x direction, if it is oriented in the x direction, our leading term with the positive in front of it is going to be the x. And let's just say x squared over a squared minus y squared over b squared equals 1. So x direction, that leading term that's positive will be the x squared. When it's going here along the y direction, it's going to be the leading term that's going to be positive is the y squared. So in this case, I'd have y squared over a squared minus x squared over b squared equals 1. So that's how you can tell, one way you can tell which way it's oriented, all right? Look at the positive term. Okay. Now, hyperbola also have two foci just like an ellipse does, but theirs is going to be inside each of these separate parts. So that would be a foci there. Here, we would have them over here. Okay, let's call this F1, F2, F1, F2. Okay, two foci. All right. Okay. Now, we also have vertices with the hyperbola. They're going to be these points right here. Vertice, vertex, vertices. Here we have one, and here we have one. And that's where they cross the axis. Okay. Now it's easy to see what they are because at these vertices, like in this case, in these vertices, the y value is 0. So basically, I end up with x squared over a squared equals 1. When I solve it, it's x is equal to plus or minus a, the number that, the square root of the number that's under the leading term. So this is, so our vertice here is going to be a comma 0, and here it's negative a comma 0, but it's all centered around the origin. Okay, in this case here, okay, again, we look at the leading positive term here. We have an a squared here. So again, in this case, it's going to occur where x is equal to 0. And so we end up again, y squared over a squared is equal to 1. Again, we have y is equal to plus or minus a. But this time it's on the y-axis, so our x coefficient is going to be a 0, and our y coefficient here will be an a. That's for that vertex, and then here it would be again 0 for x and negative a, but negative a for the y. So this leading term here that has positive tells you first of all the orientation, and then the square down here gives you the vertices. Then we have this other thing, though, with the hyperbola. We've got, just like with the ellipse, we have these two foci, right here and right here, that are inside those two shapes. Okay. The foci this time, in this case, it's not at all necessarily the case that a squared is bigger than b squared or either one in this case. For the foci, I now take the square root of adding those two numbers together. So whatever number is under there, that's a square. Whatever number is under there, I take the square root. And it'll be plus or minus. All right? And we generally, we can call this, if we want to call it by a letter, let's call it C. All right? So this foci here then is going, let's see, it's along the x coordinate, so we're going to have an x value of C, a y value of 0. Over here, it's just going to be the opposite of the x value minus C with a y value of 0. Okay. And the same thing here. The foci also here is going to be plus or minus the square root of a squared plus b squared, except this time it's along the y-axis. So our x value is going to be 0, and our y value is going to be C. Our x value is going to be 0. Our y value is going to be minus C. All right. We're going to get to a couple of exercises in just a minute. There's one other thing here that hyperbolas have that the other two don't have, and that's an asymptote. So hyperbolas have two asymptotes. They're slant asymptotes. Okay. So those are lines, those are slanted straight lines that the hyperbola graph tries to get as close to as it can, but it never crosses or touches it. So if we look here, it goes through the center here. It would go like something like this. That would be one asymptote, and then we'd have a matching one in the other direction like this. So we'd have two asymptotes like that. They both meet at the center. For the one that's oriented in the y direction, again, they go through the center. We have one that goes up like this, and a matching one that goes in the other direction like this, and meet at the center. And there's an easy, well, for me, when I was preparing this, I thought, okay, I'll never remember all this stuff, because I try to put myself in your shoes. I'll never remember this stuff, all right? what's the equation of the hyperbola? All right, this is what I came up with. We know it's going to be y equals something. All right? Now, what I did here is I looked here at my equation up here, and if I just look at this part right here, if I multiply both terms, I'm just looking at the left-hand side here. If I multiply everything by b squared, I get a b squared here and an a squared down here. So I got a b over an a right here. And that's the equation of my asymptote. So I multiply by b squared. I get a b squared up here. I have my a squared down here. I just have the y squared over there. And so it's going to be b, and it's not the b squared. It's just the b over the a. B over the a times x. So I just eyeball this, multiply, and just look at the b over the a. And it works, all right? And then we're also going to have not only a plus 1, but we're going to have a minus 1. So there are two of these, as we see. One goes in one direction, the other one goes in the other. So it's a very simple line equation, y equals plus or minus b over a times x. And I can do the same thing over here. I've got now I know it's going to be y equals something. Here I just multiply both of these sides here by what's underneath the y. In that case, it's a squared. I multiply, I get y squared, and I get a squared over b squared. I just do the a's and b's. Y is equal to a over b times x, and I do the plus or minus in front of it. That works for me. I don't know if that'll work for you, but it does work. When I was taking trig, I would just do all kinds of things to remember trig identities, you know. So sine is sin and all that, whatever it took for me to remember. So this, I don't know if this will help you guys or not. Do you kind of understand the process here, what I'm doing just to figure out the numbers? And we'll look at it. We'll look at an example here. Okay. All right. So let's look at an example. All right. Okay, find the foci, vertices, and asymptotes of the hyperbola (9x squared minus 16y squared equals 144. Okay, now, what we need to first do with this is to get it in the form like this or this here. So we want a 1 on the one side of the equation. So what I have to do here is divide both sides by 144 so that I get that 1 all by itself on that left-hand side. So over 144, over 144, over 144. Okay. Now, 9 into 144 you find is equal to a nice 36. Minus 16 into 44 is equal to 9. So that's minus y squared over 9. And then, of course, that's 1 on the other side. Now this is in the form we can work with. So the correct form. Okay, my first question then, is this hyperbola going to be oriented in the vertical direction or in the horizontal direction? Right, horizontal direction, because it's not because 36 is bigger than the 9. It's because this is the positive term with the x in it. So it's going to be oriented in the x direction. Hmm? Let's see. 9 into 1, isn't it 9? 9 into 144, isn't that, oh, that should be 16. You're right. Yeah, thank you. Yikes. 16. Okay. And sorry about that. And so it still is oriented in the x direction. It doesn't matter at all that 16 is bigger than 9. It's because it's the positive term. All right. So a good thing here to start doing is to start sketching your graph. All right. Now, this number here is going to give us our vertices. All right. Except we have to do the square root. So it's going to be plus or minus the square root of that particular leading number. So that's plus or minus 4. And this is going to be in the x direction, so I'm going to have 1 here and 1 here. This is going to be 4, 0, and this is minus 4, 0. So those are the vertices. So we found the vertices. V, B. Okay. Then it wants us to get the foci. Okay. Now, let me ask this question. Are the foci going to be in this general area or in this general area? Outside, so to speak, or inside? They're going to be on the outside, right? Because they're going to be inside those shapes. Okay. Now, for the foci, we just take our two numbers that are in the denominator and we add them together and do the square root. So I have a 16 and I have a 9 in the denominator, add them together and I do a plus or minus in front of them. So that's plus or minus 5, square root of 25. Now, again, because we're oriented in the x direction, here's going to be 1 and there's going to be 1 on outside of the vertices. So this is going to be 5, 0, and this will be minus 5, 0, and those are the two foci. Okay, obtained that way. And then so we got the foci. Now the final thing it's asking us for is the asymptotes. All right. So let's look at this thing here. It's going to be y equals, let's see if anybody understood what I was saying there about how to figure this out. It would be y equals what times x, according to my little method of doing it? No, don't do the b over a. I want numbers here. But we do the square root. So it's not going to be the 9 over the 16. It's going to be 3 over 4. All right. So, okay. So if we look here, multiply by 9. So this is my way of doing it. So we have a 9 here, a 16 there. But when we multiply by 9 there, we just have a y squared. So it's kind of like y is equal to 3/4 taking the square root x. All right. That's how I'm remembering it. But that's only one of the asymptotes. It's a plus or minus. So basically, here our one part of the hyperbola is going to go like this, with the foci inside. The other part's going to go like that. And our vertices are going to go, our asymptotes are going to go through the center, where this is y equals 3/4 x for that direction, and then in this direction, y equals negative 3/4 x. Okay. All right. And that answers all three questions then. Question on that example. All right. Let's look at another one. Here it's presented a little differently. Find the foci and equation of the hyperbola with, now we're given the vertices, with the vertices 0 plus or minus 1, and we're also given the asymptote. And asymptote y equals plus or minus 2x. Right. So we're asked to find two things, the foci and the actual equation of the hyperbola. All right. What always helps with these problems is just to even sketch what you can, just from the initial information that you're given. The vertices here are along the y-axis here. Notice it's x is 0, y is 1, x is 0, y is minus 1. So here's one vertex, and here's the other one. Okay, V and V, like that. So that tells us that this is going to be oriented in the y direction, because the vertices are oriented in the y direction. So we can say oriented, or we can think to ourselves, oriented in the y direction. Okay, so we know it's going to be something like y squared over a squared minus x squared over b squared equals 1. It's going to lead off with that positive y, all right? Okay, now, what are we also given? In addition with these vertices, what does this number here for this vertex tell us about either this number or this number? Remember that vertex is also an intercept. In this case, it's a y-intercept because it's along the y-axis. So would that tell me a value for b squared, or could that tell me a value for a squared? Okay. It's going to give me, the vertices are going to be under that leading term, all right? And another way you could find this out is this. X is 0, y is plus 1 or negative 1. If I plug this in here, I know I'm going to have this general format. If I plug in my 0 for x and my values for y, I'm going to basically get 1 squared over a squared is equal to, plus 0 for x is equal to 1, and so therefore a squared has to equal 1, just from the information from the vertices. So I know that that number under the y squared is 1. So I know it's y squared over 1 minus x squared over b squared equals 1. So I've gotten that far with it. Are we okay with that? That much so far. All right. Now, what else? The only other thing we're given is we're given this asymptote. Okay. Now, what we're talking about here then, with my method for figuring out this asymptote, it's going to be y equals, all right? But, okay, so in this case, well, I multiply by the 1 here. So I have y squared is equal, minus 1x squared over b squared. When I multiply both sides by the 1, well, that doesn't really matter in this case. And so y is equal to plus or minus 1 over b, like that. That would be my, if I were trying to find the asymptote. So I have a 1 up here, I have a b squared down here, so y equals 1 over b. But I'm told what that is. I'm told that it's 2. I'm told that y is equal to plus or minus 2 times x, all right? Therefore, I can figure out what b is. 1 over b has to equal the 2 that's in my asymptote. 1 over b has to equal 2. Therefore, when I cross multiply, I end up getting that b is equal to 1/2. We following with that? Okay, so b is 1/2. I have to be a little careful here with your arithmetic. b is 1/2, but what we want to put down here for our equation is the square of that. So b squared is equal to 1 over 4. Okay? So what we end up with here, so what have we now developed? Y squared over 1 minus x squared over 1/4 is equal to 1. And I guess that's good enough, but I could make it look a little bit nicer if I did something with this term right here. Remember that when we divide by a fraction, it's the same as multiplying it by the reciprocal. So this can really give me y. Let's forget the 1 in the denominator. We don't need that we don't need that. Y squared minus, and then so dividing by 1/4 is the same as multiplying in front by the 4. Y squared minus 4x squared is equal to 1. And then this would be the best way to write your answer for your equation. It looks better. So there can be various ways of obtaining this given the information. So let's see, what's something else we could find out about this thing. So this is our, let's actually use this equation here. Let's also figure out, we weren't asked it, but oh yeah, actually we were asked it. Find the foci. I haven't gotten that far yet. Okay, so what about the foci? We need to actually keep it in this form right here. Y squared over 1 minus x squared over 1/4 equals 1 in order to do the foci. Okay. For the foci, we do the square root of adding these two numbers together. So that's the square root of 1 plus 1/4. And it'll be plus or minus. Okay? Now, we could also fiddle with this a little bit too, okay? This is plus or minus. What's another way of, as a fraction, 1 plus 1/4?
35 over 2.
Right, you jump right ahead of me, yeah. Square root of 5 over 4, 1 plus 1/4. And then when we do the square root of that, we have plus or minus the square root of 5 over 2. So those are our foci then, all right, just by adding those two numbers together, doing their square root. And of course, this would be, let's go right back up here, these would be then in the y direction. So, and they're going to be a little bit, see our vertex this was 0, 1 and 0, minus 1. Square root of 5 over 2, well, square root of 5 is a little bit bigger than 2. So a little bit bigger than 2 divided by 2 is going to be a little bit bigger than 1, all right? So we're going to have something a little bit bigger than 1, and that'll be the x value 0, square root of 5 over 2, and then a little bit less than negative 1 down here. So that's the focus, that's the focus. 0 minus the square root of 5 over 2 down there, okay? All right. Okay. Okay. That's it on just that part of the hyperbola. Any questions coming to mind? Of course, with anything, is just doing some homework problems is what's going to be the best thing. There's one last thing here in this section that we want to cover. And this is when, notice all the ones we've done so far, they've all been centered on 0, 0. We've had hyperbolas centered on 0, 0. We've had ellipses that are centered on 0, 0. And also for our parabolas had their vertex at 0, 0. Now what we're going to do is take this is considered the center. Center, center, and for the parabola, that vertex can be considered the center. We're now going to shift it. So instead of the center being just the origin, 0, 0, it could be any ordered pair in the plane. Okay. So we're going to, it's called shifting the shifted conic. All right. So, up to now, the center has been 0, 0. And that's because it's made the algebra easy. All right. Now it's going to be any number h comma k. So we now will have any ordered pair h comma k, where h is the x value and k is the y value as the center. What this means with reference to all the equations that we've developed so far is this. To do this, in any of the equations that we have, we replace plane x by x minus the h, and we replace y by y minus the k. One thing I want to point out here is this. Here and here is opposite in sign from here and here. Opposite sign from h comma k, because they both have minuses in front of them. Okay. So let's look at, our first example is going to be with a hyperbola. Let's do this and then take a break. Example. Okay. Let's see. Sketch the hyperbola. And here's its equation that we're given. 9x squared minus 4y squared minus 72x plus 8y, oh boy, plus 176 equals 0. Find also its both sides, vertices, and asymptotes. Okay. All right. What we have to do here, if you guys remember from college algebra, when you were trying to get the equation of a circle with a certain center, what you had to do, if you remember this, you had to complete the square for both the x and the y variables in order to get it in a certain form to get the center of the circle. I don't know if that rings a bell or not. But that's what we're going to do here. We're going to basically complete the square for both x and y. So the first step in doing that is I need to get my x variables together and my y variables together. So I'm going to group x and y stuff together. All right, so let's see. We've got a 9x squared, and then I have a minus 72x. And then, let's see, for y, I have minus 4y squared plus 8y. And if you remember this from completing the square, the plane constant needs to be moved over to the other side of the equation. So this 176, I need to subtract it from both sides and get it over on the other side. Now, all of these problems are going to work out nicely. Another thing with completing the square is that your x coefficient or your y had to lead with the number 1. But look at what we have for our two x terms here. We both can draw out, factor out a 9 in front of each one of these. So this can factor, these two terms can be represented as 9 times x squared minus 8x. And I'm going to leave some space here. Then we look at our y terms, and again, I can take a -4 out of each one of these two terms so that I'm leading with a y squared. -4, and then what I'm leading with here then is a y squared, -4y squared. Here, what do I have to put here to correctly complete this? Yeah, -2y, got to be careful with that. Ooh, and I needed to leave some space. Y squared minus 2y, let me leave some space, and this all equals the -176. Now I'm ready here to complete the square and here to complete the square. So what's that going to give me? How do I do that in say, this case here for the x? What's the process? Yeah, divide by 2. So -8 divided by 2 is a -4. So we divide by 2, -4, and then I take that -4 all in parentheses and I square it and I get a 16. Now be careful. Whatever I do to one side of an equation, I have to do to the other side of the equation. I'm not just adding 16 over here onto the left side. I'm adding 9 times 16. Right? So 9 times 16 is 144. So over here, I have to then add that 144 over to that other side. Now let's do the same thing to the y. I take that -2, divide by 2, I get -1, and then I take my -1 in parentheses and I square it, and I get a +1. Then we have to watch out. I'm not adding +1 to this side. I'm adding -4 times 1 to that side. So that's a -4 that I also have to put onto the other side. Okay, let's see what we get here then. 9. Now my perfect square here is going to be what for my x term? X plus or minus what number? -4. It's always going to be whatever your b term was divided by 2. So it's going to be x -4. Then I have my -4 here, and then it's going to be y. My b term divided by 2 is -1, y minus 1, all squared. And then let's combine these numbers up here. What is that? That's -180 plus 144. That's going to be a -36. Okay, my goal here is to get it in x squared something over something minus y squared something over something equals a 1. I want to have a 1 over here. So I have to divide everything by the -36. Okay? Not a positive, negative. I want a 1 over there. Okay. Now, I'm going to end up with my positive number being connected with the y. Because notice here I have a -4 divided by -36. Double negatives going to cancel each other out. So I'm going to lead off, I want to lead off here with my y minus 1 squared, but now I'm going to be putting it over the number 9. Now I'm going to have my negative now is going to be connected with my x, and I'm going to have minus x minus 4 squared, and that's all going to be over the number 4. And so with completing the square and doing this dividing, this is the form I need. Notice it's just like the other form, except I've got a y squared, x squared, I've got a minus in between, except now I have that in parentheses where it's y minus 1, in parentheses it's x minus 4. Okay. Now, are we okay with how I got this? All right. Now, question. So let's start looking at the big picture here. Is this parabola going to go in the x direction or in the y direction?
Y direction.
Going to go in the y direction. Okay. So it doesn't hurt to start drawing a rough graph. Y direction. In fact, we're asked to do a sketch. Okay. Now, these numbers right here, this minus 1 and minus 4 right here, these are going to give you the center of the hyperbola around which it's all kind of symmetrical around. Now, this is our x, this is our y, so be careful. Remember, it's opposite signs. So my center, x and y, my x value is going to be a positive 4, my y value is going to be a 1. So that's a good thing to get started with on our graph here. Let's have x is 4, 1, 2, 3, 4, and y is 1. So basically right here is going to be what we can call the center. Okay? All right. Now, remember that whatever our leading term is here, this number provided us with our vertices. We did the square root of it and then had one up on top and one up on the bottom. But this time, we're centered here at, I should mark this, at 4, 1. And we're going up and down. So we're going to have a vertex up here, and we're going to have a vertex down there, all vertically aligned. Okay? So we know that the x-coordinate of the vertex is going to be what? If this is 4, 1. Before, right. You just have the same x values on a vertical line. All right. So this would be a 4. This would be a 4. Now, but this number here gave us the magnitude of what before was the intercept. So what do? I've got a 9 here. Does that mean I add a 9 to the 1 to get my value, or do I do something different? Do I do the 9, or do I do the square root of the 9? I take the square root of that 9, which is a 3, and that's what I'm going to have as my vertices up and down. Remember before, where we didn't have the shifting deal, with this, let's see here, this one right here, x squared over 16 minus y squared over 9. Okay, the number here under our leading x, square root of that was a 4. That gave us this vertex here of 4, 0, and this vertex of minus 4, 0. So we do the same thing, except we're on a different line now rather than just the regular axes. So, this square root of 9 is 3, so I'm going to go up 3 and also down 3 from my center to get the vertices. So if this is 4, 1, this up here for this vertex is going to be what? I'm going up 3. 4, 4, right. Just add 3 to my y value. And then down here then, for my other one, this is going to be, right, 4, 2. This point looks a little bit off here. Right, so again it's 4, but I go down 3, 1 minus 3 is a negative 2. So that's my other vertice. So we know then the vertice means that this hyperbola is going to go like this and like this. That's what those vertices are. It's going to spring up from either one of those. All right? Okay. So we have found the vertices. Let's see. Let's find the foci. So here's my equation that I'm working from. The foci, remember, they're going to be up a little bit further, and they're going to be down a little bit further. They're going to be inside those shapes. So I have my numbers right here. So what's the procedure then for me to go on and get the foci?
Plus or minus square root of a squared plus b squared?
Yeah, right. So plus or minus. And instead of just saying a squared plus b squared, just know you just add these two together. 9 plus 4 is 13. And so that gives us the square root of, plus or minus the square root of 13, 9 and 4. Now again, the foci are also going to be oriented along on that same vertical line. So they're certainly going to have the same x-coordinate of 4. Now the y-coordinate, now this is the distance basically. That's how much up from the center it's going to go. And the minus is how much down from the center it's going to go. Our center that's the first thing we determined was 4, 1. We're going to have to go take that 1 and add the square root of 13 to it. They're not going to combine into a single number. All we can take is that 1, that y value, and add on to it the square root of 13. So this is going to be 4, 1 plus the square root of 13 for my upper focus. Down here then, I take my 1 and I'm subtracting the square root of 13. So this is going to be 4, 1 minus the square root of 13 for my bottom focus. So this, adding these two numbers together, doing the square root, that gives me that distance up or down that I need to add on to my center. How are we with that? Okay. And what's the last thing we're asked to find? Asymptotes. Okay. Now, the asymptotes before, they crossed at 0, 0, the origin. Well, now they're going to cross at the new center. They're going to cross at this center here at 4, 1. So we're going to have that big X right there. The slope of the asymptotes is going to be computed the same way. Let's look at our equation here. Okay. If I multiply both sides by, if I multiply a 9, put the 9 up here, what I have here then, I can actually read off my equation right away, actually, right here. Y minus 1, take away the square, equals, now I have 9 over 4. I don't want 9 over 4 though, I want the square root. 3 over 2. And it'll be a plus or minus slope of 3 over 2. Square root of 9 over the square root of 4. And then right behind it, I can finish off my equation of my center. Again, getting rid of the square, and it's x minus 4. So this is, from algebra, we remember this as the point slope formula. That's what this is. This is the point slope representation of that asymptote. Okay? We can read it right off of this. We want to lead off with the y, but it's y minus 1 instead of just plain y. Multiply over by the 9, do the square root, 3 over 2, and then x minus 4. Okay. So that's the two equations. That's all we need to put for them. We don't need to simplify that any further. I think we need a break. Let's take a 5-minute break. Eureka and Lafayette, I need to let you know that there's a typo in the homework that's due on Monday. And it's on problem 16A in section 10.1. Have any of you noticed a typo in that first set of problems? Did you notice the typo? Okay. So, both equations have y in them, and that's wrong. So make the first equation the x equation. Yeah, because all the other ones lead it with the x, right. Okay. You're welcome. Otherwise, the problem makes no sense at all. Oh my.
20 seconds.
Today,
15
I haven't even had time for it to sink in. And it was a Friday also.
Really?
Oh, yeah, I don't
I was in first grade. Sorry.
I was.
Oh, okay.
Yeah, it was a Friday. Mm-hmm.
Going to Catholic school, so it was a big thing.
Oh, gosh, yes. They called us all into the multi-purpose room, they called it. Oh, of course I know what day it is. Time, so it's what, 12:04? Mm-hmm. And, of course, the normal time is 2 hours. Right, and I'll deliver it myself.
This is final, because he's already
Oh.
been told to get the final stuff ready.
Oh, I see. So this one is that one was the right, that was the text, right? Okay, great.
And final for
Okay.
Monday.
No, wait a minute. Is it on the 9th? Okay.
I think it was on the paper that said
Is
that.
it? Okay. I'll trust you if that was on the 9th. About 9:13. And that's also 2 hours. Structure. I got my little set of different colored pens.
We've gone to Artmark,
Mm-hmm.
and they have all kinds of.
Uh-huh. Okay. All right. Okay. You got it? Oh, How are you doing?
I haven't even sent any homework to me yet. Pretty straightforward.
Once you do a few of the problems, it starts to sink in better, of course. Well, that's good. Sometimes sometimes I have no idea whether I'm getting it right. And this take-home quiz really is I think it's the easiest of the four, really. And I don't think I'm lying when I say that.
I'm good, but I'm tired of waiting.
No, I haven't started officially writing the test. I'm doing it. I'm doing the take-home quiz. I'm going to do the practice set, and then the test is always tests will fall into place from there.
I always 3 hours.
Well, you really shouldn't be having to spend 3 hours to do this. But, it shouldn't take that long. Okay. All right. Let's get started here. I think actually for today, I think I'm just going to finish this section up, and we have one more section here, 10.6, and that one I think we can certainly get that one in between Monday and Wednesday of next week. All right, so that's the last section, and for you guys out there, you're certainly we would be actually thrilled if you would gain us with your presence on Wednesday of this coming week. We're going to have actual treats here, brownies and bagels and other things. So, do I have a show of hands of how many are going to be coming in on that morning? Samuel says he loves brownies and he will be there. Well, I would love to see you, Samuel, and anyone else. Otherwise, if you cannot be here, it will be recorded, hopefully, and it'll be posted sometime over the weekend, over the Thanksgiving weekend. All right. All right. Okay, so I just want to do one more problem here with this section, and let's see what, or is it 2 more problems? I think I just lied. 2 problems. All right. Now, we're still shifting the center, but for this next one, we're going to be working with an ellipse. So here we have sketch the curve, find the equation. Oops, and I think I better do this for you guys. Oop, oop, oop. Okay. Find the equation of the ellipse with, let's see, what are we given? We're given the center of it is 1, 3. We're given one of the vertices, vertex is -2, 3. Wow, we're given a lot of stuff. And the focus, and the focus, one of the foci, is -1/3. We certainly know that an ellipse does have two foci, and it has 2 vertices. So we're given one of each. Okay. So the first thing that I recommend doing is just initiating this rough sketch. First of all, the center. So here's our y and x. The center is x is 1, y is 3. So that's our center, 1, 3. All right. And then let's mark down the vertex and focus that have been given to us. So the vertex here is -2, 3. So let's go -2. And then again, we're up 3. So that is let me mark that as a V for a vertex. And that's -2, 3. And then we're also given, oh, this is really going to be crowded. We're also given the focus, which is -1, 3. So right there is one of the foci right there. And that is -1, 3. All right. Okay, so first of all, just looking at those 3, is this ellipse going to be oriented in the x direction or in the y direction? Going to go in the x direction, right. So it's oriented in the x direction. So we know that, and so we know that it's the bigger number is going to be under the x. Remember, with the ellipse, the bigger number is under whatever orientation it has. Bigger number is under the x squared. But in this case, it's not going to be plain old x squared. We're given the center. So for the x, remember, it's you change the sign. It's going to be x -1 squared. And then the bigger number is going to be under the x. Let's see. Can we figure out, here's one of the vertices. Here's our center. What's the distance between 1, 3, the center, and -2, 3? How many units is that? 3 units, right? 3-unit difference. So that's we have to square that. So 3 units distance, but we square it. So that's going to be 3 squared, or 9, underneath the x. All right. And then plus, with an ellipse, it's a plus, not a minus. And then we have our y. Our coordinate of the center for y is 3, so it's going to be y -3 squared. And now at this point, let's see here. We'll have to do just a little bit of work to get this bottom number. For right now, let me just put question mark squared. We'll figure this out in just a minute. And this all equals 1. All right. Now, we've been given the focus here is -1, 3. So what's the distance between the focus and the center? 2 units, right. So 2-unit distance from the focus to the center. All right. So therefore, if we remember this, we take our bigger number minus our smaller number, do the square root. So 3 squared minus question mark squared. We do the difference, bigger minus smaller. And that's going to equal that 2, that focus distance. Okay. It's actually going to, I'm sorry, it's actually going to, oh yeah, it's going to equal 2. All right. So therefore, we can find out what the question mark is just by solving this. We can square both sides, for instance. Square both sides. And we see that 3 squared minus question mark squared is equal to 2 squared. So when we do the arithmetic here, we find that question mark squared has to equal the number 5. And that's the square. So this number under here, since we knew the distance to the focus from the center, we could figure out by doing the difference and taking the square root, we now know that that question mark squared is equal to 5. So we have x minus 1 squared over 9 plus y minus 3 squared. And now this is just over the 5. That's what the square of that question mark is. Okay. Because from here we got 9 minus 4 is equal to question mark squared, just doing the little algebra there. And then that equals 1. All right. Okay. So that's that's certainly all we need for the equation of the ellipse. We found both the numbers underneath there. Sketch the curve. All right. Well, let's see what we can do here. Basically, it's all going to be symmetric about that center point. So here's our center. The focus in this direction was 2 units over. So I'm going to go 2 units over this way to get the other focus. All right, it's going to be symmetrical. So this is going to be 2 units. So this is going to be what? If our center was 1, 3, this is going to be 3, 3, right? Yeah. And then if our and then we go a little bit further for our other, we have another vertex. Again, the vertex is going to be symmetric. The distance from the vertex to the center was 3 units. So this is going to be 3 units from the center on the other side. So this is going to be 3 plus 1. It's going to be 4, 3. So this is our one vertex. Here's our other. So remember with the ellipse, it all goes like this. Oh, that's really a horrible drawing. It all goes like that. So we join the two vertex. The foci are in the middle. And, okay, that's good enough. All right, question on that one. Let's do one more, and that'll be it. After that, you just need to work on them then. Okay, what do we want to do here? This now involves a parabola. So this is the last section, or the first one we started out with. And so here we're asked to sketch the curve, find the equation, of a parabola, and we're given some information. With the parabola has a focus of -1, 2, and remember this parabola has this thing called a directrix, and a directrix y equal to 6. All right, so let's start with graphing what we can. The directrix here is a horizontal line, y equals 6, so 1, 2, 3, 4, 5, 6. So it's going to be like this. All right. And let's see what our focus is. Our focus is x is -1 and then up 2. So that's our focus right there. All right. Now, with a parabola, remember, it's defined so that every point on the parabola, if we add the distance to the focus and add the distance to the line, that equals a constant, right? Okay. So the first thing we can find out here with this, let's see, what can we find out? Is actually, we can find out the vertex. The vertex is going to be, first of all, this thing is going to go up and down. It's going to actually go down. if this is the focus and this is the line, the vertex has to be midway between the focus and the line, because the distance between, I'm sorry, I think I misspoke just a minute ago. I think I said something wrong. The distance between the point on the parabola and the line has to equal the distance to the focus. I think I said something wrong, all right? So therefore, the vertex is going to be right here, and it has to be right in the middle, because its distance here has to equal its distance from it to the focus. So if this focus, what did we say this was -1, 2, and our directrix is y equals 6, let's try to figure out what would be the coordinates of that vertex that's between those two. Yeah, -1 and 4. Certainly the -1 for the x is going to hold. And we're looking for a y value that's between 6 and 2, which is equidistant, and that's going to be 4. Okay, so we see that it has to have the same distance. So this is our vertex, -1, 4. All right, and that is also what gives us our center. Now, let's see, is this parabola going to be going, first of all, is it going to be a vertical up and down or a sideways parabola? It's going to be a vertical. Is it going to be going up or going down? It's going to be going down, because remember that focus is always inside the parabola, so it's going to be going down. All right. Now, when it's vertical like this, basically then our x values get big compared to our y values. So therefore, the basic formula that we had before, when we were just looking at centered at 0, 0, let's see, when the the y values are going to get big compared to the x values. So it was x squared equals, I think it was 4p times y. All right. Because as the x values get bigger, our y values are going to get really big, and so it's going to be like this. Now, since it's going down, that p there is going to be a negative number. All right? Okay. Now, let's see. Instead of plain x and y, though, we're going to be use the vertex, which is, in this case, is considered also the center. We've determined already that the vertex is -1 and 4. This is our x, that's our y. Now remember, it's opposite sign. So here, for x squared, it's not going to be -1, but it's going to be +1. Opposite sign. Equals 4p, and then y, we're going to have, again, our y here is 4, but it's going to be opposite sign, y minus 4. Okay, so this is what we've been able to get so far, knowing the center and knowing that it's oriented vertically. All right, so we now have to be able to get P. Well, P basically is, if we look at our vertex here, P is going to be this distance here as well as this distance here. All right? So let's see. The distance there is equal to the distance there, right? All right. So what would P then equal? If our vertex is -1, 4, and our line there is 6, how much of a distance then do we have between those two? Distance is 2. Okay, but P is going to be a -2, not a +2, because it's going down. All right. So therefore, now that we figured out the p-value here, we're finished with the equation. X plus 1 squared, 4 times -2 is a -8 times y minus 4. And we have that. Isn't P is going to be, let's go back. Give me a second here. Okay. With a parabola, every point has the same distance to the focus as it does to the straight line. Okay, they all have the same distance with a parabola. So one of the points that we can look at is that very top point, the vertex. So this also has to hold for the vertex. And that's what this P, that's what the P represents, is going to be okay, yeah. Actually, I'm looking here from the notes. The P actually originally was just the a y coordinate of the focus, but the yeah, this was considered. Here we have a -1, and this is the P right there. But
Wasn't that distance on the notes when we first started travel, wasn't it P plus Y?
it was P plus Y, but that's for any point. But if we want to look in particular here, that distance then is that just gives us the P right there, not the P plus Y. So the P right here is going to be the distance between the vertex and the straight line, the directrix. I mean, it's just going to be.
So you agree that it's 2 and not 4?
Right. The P is it's -2. Because here we have a 4, the Y value is 4, the Y value here is 6. So the distance there is a 2, right? But it's 4P. But here the P isn't a +2, it's a -2 because it's going down. So we know it's a magnitude of 2 from this distance of the vertex to the line. We know magnitude is 2, but it has to be a negative because it's going down. So it's -2. So therefore, if 4 times -2 is -8. Let's see here. Trying to think if there's a better way I can do this. How that P was defined initially. P was actually defined as using the directrix and the focus. So it was y equals -P is the directrix, but that doesn't apply here because things are shifted. Basically, even from the best way actually to compute P is really just to look at the vertex and get its distance from the line, and that'll give you the magnitude. All right. So I guess I can keep saying that, but that's really the easiest way to calculate the P. It's just that distance, and then then either it's going to be a positive number or a negative number, depending on whether it's going up or going down. And of course, if it were this way, going this way, P would be a positive number. And if it were going this way, P would be a negative number if it were going horizontally. But P would still be the same thing. And then we'll say we have our vertex here. Let's just suppose that we have a sideways running parabola. So the basic thing here would be, would be y squared is equal to 4p times x, because x is getting big compared to y. But say this has a center of, let's see, this is maybe 3, 4. That's the vertex right there. And let's say that the directrix to this thing is the line. It would be vertical line, x equals 1. The distance here between this vertex and this line of 1 is a distance of 2, right? So this would be our p-value right here. You can just get it right there. Because it's going to the right, it'll be the positive 2, all right? And then, of course, we have to incorporate our center in here. So this would be y minus 3 squared equals 4p times x. Ooh, that should be y minus 4, equals 4p times x minus 3, getting the center in there. And then I replace the p with a positive 2, y minus 4 squared equals 8 times x minus 3. And that would be the equation that way. All right. I hope I haven't confused everybody with that last example. But again, that's the easiest way to calculate the magnitude of P. And whether it's positive or negative depends on the direction that it's going. All right. That's all I've got then for today. In fact, we're almost finished with time anyway. So what we'll start up with on Monday then is section 10.6, which is, hooray, the last section. And you guys, I'll be delivering to your school this afternoon the take-home quiz, and so you'll be getting that, I guess, on Monday then. I'm sure you want to work on that over your break. So thanks.